2010, Form B, question 2, so this is a calculator problem. It gives the function g is defined as x greater than 0 with an initial condition to start to think fundamental theorem of calculus. It gives g prime, and it gives g prime prime. You don't even have to find the second derivative from the first. Letter A, find all values of x in the interval 0.12 to 1, which g has a horizontal tangent line. All right, so the big thing to realize right away is that they are asking, when they want a horizontal tangent, they want the derivative to be 0. They want the slope to be 0. And I'm sure that's going to be a point. And then in the calculator, it becomes a pretty easy exercise. We're going to use this derivative. You can either graph it or use solver. I'd be more tempted to use solver. And if I do that here, I can just throw into a corner maybe and slide this over. And I would turn on my calculator and go to math. My solver is number 0. I did this one already to make sure I had it. You enter in, I hit clear, I go up. To get to there, I go down. I hit enter, that this is the equation. And then I take my guesses. And I'm going to guess right on the intervals. So 0.12 would be my first guess. So I would alpha solve, and I get 0.1073, which is less than our bound. You got to be careful here. So then I might guess a little higher, 0.135 maybe, alpha solve. Okay, and I get an answer of 0.1634. So x is 0.1634. Now I want to make sure I go high enough to guess there's another one. So I might guess right in the middle of the interval, which is, say, 0.6. Alpha solve, check it. 0.39. Ah, there's another one, and it's in the interval. X equals 0.3594. And then maybe I'd take one more guess, make sure it's not there. 0.8 alpha solve. Same one, I guess maybe 1, guess right on the endpoint. It jumps up. So there we go. So there are two answers here. I found them both using solver in my calculator. Now we got to give some justification for this, so I would say these are by T84. Dead spot there. And I would say that's it. There is actually no justification. That would be the thing. This would be 2 points. One for g prime x is 0, 1 point for both solutions. And make sure you check a few points in the interval. You just don't want to take the first one you get. Letter B. On what subintervals of 0.12 to 1, if any, is the graph concave down? All right. I would probably start with the know, just to show them I know something. When g prime prime is less than 0, graph is concave down. Alright. On this one, I would be tempted to go ahead and use my graphing part. So I'm going to clear out of here. And I made a graph already, so I would enter the second derivative right there, 1 minus 1 over x squared cosine x plus, make sure I'm in radians. Set my window 0.1 to 1.25, negative 10 to 10. And like we just graphed it here. And I can see that it's negative right in here. So what I'm going to have to use is I'm going to have to find that portion where those two are negative. All right, and I can tell it's really close. So I would start at the end point. I might just push trace and say, yeah, what's 0.12 at? Well, 0.12 is positive, so let's find that 0. That's on the left, so I calculate a 0 here. The left bound, yeah. The right bound, I'm negative there. Go whack a click, guess, sure. And I get the first 0 at 0.1295. Now I'd probably make a point. G of x equals 0. And then I would come here and I can see the next one's over here, and maybe I guess 0.5 to see where I'm at. 0.5 is way over there. You can see it there, so I'm going to guess less than that, maybe gosh, I don't know, maybe 0.25. Let's go 0.2. 0.2 is still negative, everything of 11. So this, again, I'm going to do my 0. Second, calculate I want to find the 0. Left bound, boom, boom, right bound, and then guess right there, 0.2227. Alright, so I got enough now to go ahead and I'll capture this again. I don't really need this anymore. I know it's negative in between from the graph. So G prime prime is less than 0 on, and be careful, it has to be open brackets here because it's 0 on those two. Thus concave down. And I would spell out concave down here. Answer and justification. So it comes down to that first sentence didn't help me, but I didn't know that. It had to be the answer and the justification that G prime prime is less than 0, thus down. Alright, letter C. Write an equation for the line tangent to the graph of G at x equals 3.3. Alright, if we're going to get a graph here, we're going to have to use fundamental theorem of calculus because we're going to have to somehow come up with the slope. Alright? And the slope's not that bad, actually. I mean, the slope is just G prime of 0.3. And you literally just plug this in your calculator. You plug this with 0.3 as x, alright? And when I do that, I'm not even going to do this. I get exactly, now I go 4 decimal points, negative 0.4721. Where this problem comes challenging is they want equation of the tangent line of the graph of G. Well, I don't know G of I don't know the y value. I don't know G of 3. So I need G of 0.3. Well, the only way to get G of 0.3 is to do the fundamental theorem of calculus. And I got to start at G of 1 because that's what I know. That's the initial condition. And I'm going to have to do an integral from 1 to 0.3 of G prime t dt. Now, two problems. I don't want to do it this way, so I probably would write out that this is 2 minus, and I want to go from 0.3 to 1 of G prime t dt. I would write by T94 here because I tell you what, there is no way I'm doing this by hand. I type this exactly in my calculator using the integral button from math, and I get G of 0.3 is equal to 1.5460. 4 decimal places. So the equation of the tangent line, write equation for the line tangent. I would do point slope form. Personally, I would go y minus 1.5460 equals negative 0.4721 times x minus 0.3. And if I want to make sure it's y equals, I would stop here, all right? And let's see here. You'd get 4 points. B prime of 3 is a point. The integral expression is a point. G of 0.3, that value, and the equation. And this is a case of, even though we're to letter C, it was fairly important that we get this one right to pass the AP. Alright, that takes us to letter D. Does the line tangent to the graph of G at 0.3 lie above or below the graph of G for 0.3 less is greater than x and less than 1 y? Alright, so the real question here is, does the line tangent the graph lie above or below? They're asking about the concavity. They want to know, is the line above or below? Well, we got to know what's G prime prime on this interval, alright? And we proved up in letter B, in between, if we bring that down, remember we proved in letter B that it was concave down, and we did this graph, right? We proved it was concave down between 0.1295 and 0.227. Well, think what they're asking. They're asking from 0.3 to 1. So I'm going to bring back my calculator, and this would be our answer up above. We'd have that in our paper. I'm going to put letter D here in green, so we keep them separate. I'm going to have to turn my calculator on again. But remember, this is a problem where we had already been here. And we know that from 0.3 to 1, it's positive. All right, so I would write g prime prime x is greater than 0 on 0.3 comma 1. And I probably write my TID4 graph. Thus concave up. So that means the curve's above. Thus, the line at next, so I would change this to from 0.3 to 0.22. Thus the line, because we know it's 0 there, so we know it's positive the whole way. Thus the line at x equals 0.3 lies below the curve. And maybe I should have said tangent line. Since if I had time to go back and fix it, I might put tangent line because that's what it asks. There. And everybody, this is just 1 point. We had our 8, so, alright. Again, a really good problem, taking a lot of practice to work. Again, the number one thing is slow down and remember the fundamental theorem of calculus. When you see an initial condition right up here, there is a high chance, alright, that you'll need the fundamental theorem of calculus. Keep pushing, don't surrender.